All right, this is Jason with the OpenHarrier project. Decided to record a video of me working on the UFC in FreeCAD. I'm using 0.21.2. Right now, the OpenHarrier cockpit's broken up into different files, and I can actually bring all the files together. Actually, I'll show you what that looks like. Well, maybe not in this video. I'll show that in another video. But I can independently work on the files, or I can work on the whole cockpit together. The files are joined together in an assembly using the assembly 4 workbench. This one right there. But for now, let me just do a quick overview of the UFC or upfront controller for the Harrier. First off, I just want to mention that the etchings on the buttons there, that they're kind of floating over the buttons. It's actually not part of the buttons. And you'll see they sometimes disappear or get hard to see depending on how you rotate. They have a little luminous there, so they kind of show up green when you kind of tilt it in the dark. What this UFC is made up of is several different parts. If I expand this tree, so this is the assembly for the UFC. So this contains everything that is going to go into the UFC. And as you can see, I still have a lot of work to do here. There should be a control panel here. There should be the left denunciators and the right denunciators. I haven't built those yet. That's coming. But if I expand the UFC over here, we see that we have the UFC base box. That's this piece here. And this is actually the first piece I actually built in this model. If I were to hide everything, there's a way to do that. I'm not going to do that right now. I can't remember. There's a control key that you can make it so that it shows only that part and hides everything else. I'm not going to do that right now. Well, you know what? Maybe I will, because it's not that complicated. Because I can just collapse these. I can go boom, boom. And I had the scratch pad there. Okay. So here's the UFC base box. That's probably not the best name for it. The intent here, I just noticed these holes aren't quite, or actually these supports aren't quite lined up with the holes. I actually probably need to adjust the supports a little bit. The intent here is to have threaded brass inserts that go in these holes. I'm not sure if these holes are the right size. I may have to adjust that. These supports here are for mounting the base to the piece in the back. So if I go here and go upper body, well, actually, hold on, I need to turn this on. Oh, that's the rear body. This is the lower body. So you can see I'm intending for this and this and this, and there would be holes in here. They would mount up with supports on this bottom piece, which I also haven't finished yet. So let me hide the base box here. This cutout here is to allow for cabling to come down from the UFC. I still need to add, I think, a hole in here, or actually no, not in there, because it's just the cabling would probably just come out this side here. Obviously I have to put some holes here to mount, and in here to mount this piece to the instrument panel. Let me put the base box back, and then the upper body is this sort of triangular shape, and you can see that I've got support material here that these are supposed to join up with. Again, I need to do some more work here to get this stuff lined up. I haven't really done that. There's some supports up here. There is another thing that I need to work on. These holes here are intended to have really long screws that go through, on the real Harrier anyway. These would go all the way and mount into the actual HUD projector assembly. That would sort of give support to the upper part of the UFC. Otherwise, This is the contact area for the fuselage, or excuse me, for the instrument panel. So this stuff here wouldn't actually join with anything, and there'd be no support here. And if I'm 3D printing all this, right, there's going to be some flex unless I've got some support. So I do plan to build a projection assembly. What I might do is allow for threaded rods to come all the way to the instrument panel to kind of give it rigid support if you haven't built a projector assembly. So there's more to come there. I have to do some design work there. Haven't done it. Anyway, the reason this is split up into 3 pieces is to ease printing. You know, if I add this and this piece here, when you 3D print it, you would print it like this on the table, right? So this would be a very easy thing to print with almost no supports. There might be little supports in the little holes here. Actually, you could do this. These holes actually could print without supports, believe it or not. That's probably okay. And then if I look at this piece, it's highlighted in green, I would print this like this. Oops. So this would get printed like that. And then this piece actually would get printed, if it were on the table, it would get printed like this. So it would sort of be printed standing up. So as I'm designing this, I am thinking about how this is going to be printed. And of course, you know, if I were to just print all this like as one joined unibody, that would be kind of hard to print. I'd have to have a lot of support material, and a lot could go wrong. I think it's better for something of this large. Like, this is a fairly big structure. And also, my 3D printer is not the biggest. I have a 200 millimeter by 200 millimeter by 200 millimeter 3D printer, but realistically, it's really only 180 millimeters because I've got clips that hold a piece of glass onto my print bed. So I really have only 180 by 180, and I can tell you that this piece here just barely fits on my 3D printer. I'm also considering getting a new 3D printer. Anyway, put the panel back on, and we're going to walk through the different parts of the panel. So if I expand, so the UFC panel is a separate assembly. If I expand that, it's made up of a whole bunch of different pieces. Let me start by hiding everything. Unfortunately, I don't have the knobs in like a sub-assembly that make it easy to toggle them on and off. Alright, so the first part of the panel, so it's called the base plate right now. Actually, I'm going to rename that because I started calling it the panel tray. I like that name better. And what's going on here is this will actually hold the panel on one side of it. So the panel will actually be made up of 3 different layers, and I think I'm going to work on that in this video. Underneath this is going to be the circuit board. Now, please understand this is just a representation of the circuit board. I'm actually going to design the circuit board in KeyCAD. I have not built that yet. So this is just a representation, kind of visualizing where things are going to go. Like these buttons are kind of lined up, or these little micro switches or tactile switches. Actually, is actually what they're called. Interesting. I have the rotary encoders right now are part of a separate body. Those actually should be included on the PCB. What's going on there? Let me take a quick look. Where did I? Oh, okay. So this here and this here, these should really be part of the circuit board. So I'm gonna, and the reason they weren't part of the circuit board before is because I kind of thought, I got to reposition them now, because the parent changed, the positioning of them changed. So here's what I'm going to do. I'm going to hide I usually hide this base box because it makes it easier for me to see what's going on underneath. And this is something I wanted to show you. These are standoffs, so I intend to mount the PCB floating behind this tray, and it's held on by standoffs. So there's a standoff here, here, here. I haven't put them here yet, but they're going to be there. Gotta have not a standoff here or here. That's actually for the scratch pad mount, but I've got a standoff here and here, or will have a standoff there. I haven't added those yet. In fact, I need to make this circuit board a little bit longer. These little cutouts here are actually for the pins for the OLED displays for the scratch pad. The pins for the OLED displays for the comp radios actually would go here and here. Those don't actually connect to the circuit board. Actually, what is going on there is I just intend to use wires connected to those pins, and then I'll have like a junction soldered on here. And actually, that brings up an interesting point. I may need to have a cutout in the circuit board to allow for those to pass through, because I don't know if I would have enough clearance for the wiring that I want to use here. So let's quickly adjust these rotary encoders. So we're going to go down to the circuit board. We're going to expand that. Rotary encoder count 1. First things first, though, I need to switch my view to ortho. This will be an easy adjustment. So we're going to do transform, and I'm just going to pivot this up. It needs to stand on these little legs here. I might have to zoom in to get the distance correct. Okay, so that should be pretty good. And then what I can do is look at the exact position, and we can see that that position is 1.5 millimeters. So here I can actually just type that in for the COM2. It says -5, so we change that to 1.5 millimeters, and it'll be in position. Whoops, got a millimeter there twice. All right, so that part is fixed. When working in FreeCAD, I am anal about saving, like pretty much constantly. I rarely get much work done without saving. Like every 5 minutes I'm hitting save. I'm kind of crazy about that. I've had a few crashes with FreeCAD, although this latest version has seemed to be pretty stable. It's rare that I have an issue. I will sometimes make backup copies as well. I do have it set up to automatically create backups, which I think it'll create a backup every time you okay. I just want to point out that there is a chamfer that's supposed to be on these edges, and it is not working now. And the reason it's not working is because I gotta turn on the top plate. Or no, I don't need to turn on the top plate. I don't know why I did that. Actually, we need to finish talking about what else is on here. So here's the top plate. This needs actually to be divided into 3 pieces or 3 layers. I can tell you that this grid was really, really hard to do. I did this grid with a single sketch, and the way that thing is laid on there, it's going to be kind of difficult to remake that. I kind of don't want to do that. So what I'm actually going to do is I'm going to take this part, and then I'm going to split it. I should mention also the engraving on there is also just kind of floating on the top. It's not actually engraved in here. I will do the actual engraving probably in Inkscape anyway, or at least export this so I can load it into Inkscape. I haven't really done any laser engraving and laser cutting as of yet. On the Harrier project, I have done it for some wood cutting and wood engraving. I just haven't actually made a panel yet, so I've got a little bit to learn there. Anyway, going back to what the parts are, let's hide the top plate for a second. I want to show the scratch pad. Actually, I want to show the COM display. Load up one of these. This is actually made up of 3 parts, and I see that I still have the base set to transparent. So there's the bottom holder, and I probably need to change the name of this. I'm not sure I like that name. Let's call this. Let's just go ahead and rename it. Rename COM bottom. Let's just call this COM base part. top part. I like those names a little bit better. All right, so we've got a top piece. Here, let me hide this. Whoops, wrong one. All right, and let's go ahead and take that bottom, or that base part. See, now it's called it bottom again. I'm gonna fix the transparency on it. Oops, can't. What's going on there? Okay, appearance. Okay, all right, and this would realistically be black. It's not going to be white like that. I'd kind of have it white right now, just make it easier to stand out. Let me hide the display part. I keep doing this the wrong way. OLED part, sorry. Okay, so this is what, this is a 3D printed part to hold the OLED displays. These OLED displays, I have just loosely modeled this. So if I put the OLED part back on. So this is an SSD 1306, I think it's called. Obviously, we're not talking about a SSD hard drive. That's what the part's called. These are super cheap. There's dozens of clones of these. I think Adafruit had the first ones, or at least the first time I ever saw one of these was off of Adafruit. But these are not Adafruit ones that I bought. I modeled this just using calipers and measuring. You know, I ordered like a 5-pack for, I think it cost me $8. And I just used a caliper and measured all the parts. There's some electronics that sit underneath here. I had to create a little gap there. I had to create a gap here for the ribbon cable. And I had to create a gap for the pins. The pins are just representative. They're not 100% accurate. And I didn't recolor these. These are supposed to be silver, but I added these pins later on. Look, I didn't even color. Actually, you know what? Hold on a second. Let me fix this real quick. So on the OLED part, toggle active part, up. What happened? I hate it when it changes my selection there. Okay, OLED part. Okay, yeah, what we want actually is to select the bottom pad and then set colors, and then I can highlight the parts I want to change. That's okay. I know it's got a big like stop sign or whatever, error symbol, whatever. That's okay. It's a little bug in FreeCAD where if you click on something that doesn't know what you're clicking on, yeah. See? Come on. You can do it. Get that little inner ring there. The cursor sometimes doesn't reset. So what I'm doing is I'm selecting all the faces that I want to set the color to. And we'll be able to grab them all at once. I don't really care about the bottom of the part. So I'm going to change this color. Of course, I didn't save the color in here, so I think it's just like kind of like that. And we can actually change the material if we... No, we're not going to change the material. We got to go into a different control for that. That's good enough. All right. That sets it back to the way it should be. And then if we turn on... Sorry. This is this... So the OLED part's made up of a couple of different bodies. I don't really care about that right now. All right. So there's the top piece. One thing to note here is this piece comes out a little bit further in the actual part. I think I might have measured it wrong, so I left a gap here. It's possible I could have some 3D printed material here covering this. What I've been doing at the moment is I've just been putting a piece of tape over it. Like I'm thinking I could just wrap this thing with black electrical tape and then paint this whole thing. Obviously I would cover this. There is a little display lens here this has changed a little bit. I actually have a little gap in here. This is like 2 or 3 sheets of gel material for tinting the OLED display from white to green. I had originally designed a tray in here so that you'd have like a lens, a laser cut acrylic lens. That's still possible. You can still do that. There's plenty of room to do that. I'm just not certain I'm going to do that. I have to think about it. I've already used the gels. It seems to work really good. Let's go ahead and turn on the other the COM2 display. And then the scratch pad is interesting. The scratch pad is actually made up of 3 of these displays, but it's the same premise. And by the way, these parts, obviously, they get screwed down onto the tray. Let me turn on the scratch pad. Okay, there's the scratch pad. And, of course, the bottom part's also transparent. Again, it wouldn't be 3D printed as transparent. I just set it to transparent for me to see what's going on. Make me understand, or help me understand, or visualize the different parts. So here I've got, this is like a lens. Like if I were to have an acrylic lens, that's where it would be. I might remove that and just use the gel like I did for the comms. I kind of want it to match because they do in the real thing. Inside the top. Here you can see I'm actually using 3 of these displays. Yes, I know there's a gap between these, and the pixel resolution on here doesn't actually go all the way to the edge, so there's a little bit bigger of a gap. But if you look at the actual UFC display, they print like maybe 4 characters for the thin characters here, 4 thin characters here, and then they have an allowance for 2 wide characters and a one more thin character. And it actually looks pretty good. I've put this on a breadboard and have already written the code to mimic the dot segments that the vacuum fluorescent displays had on the real Harrier, and it is pretty convincing. A little bit of a gap, but I think this is much better than any product that you can buy today. It's much closer to what the vacuum fluorescent displays look like. I mentioned that I've got cutouts for the pins here. I wanted to show that. I actually don't need to have a cutout here. Well, I need to extend this board a little bit in order to have standoffs here. So I've got a nice secure mount for up here. And I might cut the PCB or have a cutout for the PCB here, because the wiring is going to extend out from here and probably plug into the back of this board here. I also probably will have a pinout for, I'm thinking of using an Arduino Micro on this. Still haven't made that decision yet. I'll probably get mounted on the back. I've seen others do that with their UFCs. It seems kind of logical. There's enough room on the back. I could also alternatively use Arduino Mega, but I think that might be overkill. But I do have to probably do some multiplexing or think about the fact that I've got 1, 2, 3 rotary coders on here, and then there'll be, I think there's 2 more or 3 more rotary coders here. So I'm going to have 6 rotary coders in all, which is actually a lot. So I may have to come up with a different strategy here, electronics wise, on how to read basically all 6 encoders without losing a lot of steps. There's a lot going on with the Arduino that's running these displays, and it has to be able to update these things really fast, and that might reduce the amount of time available for reading the encoders. So I may possibly take the encoders and put a purpose-built micro that just handles that, and have like a micro that's running maybe the keyboard matrix and the displays, and so that would be 1 micro, and then 1 micro might be just doing all the rotary encoders. I don't know. Haven't made up my mind. I can make it all work on 1 if I do some other kinds of strategies, like I could maybe have sub-micros and communicate through I2C. That's a possibility. I don't know. I'm still deciding. Anyway, back to the rest of the layout here. If I turn the buttons on, first I have to find them. So let's turn on the button groups. Alright, so the buttons look like they're kind of floating here, and you are sitting on these tactile switches. Now these are not going to be the right tactile switches. I do want to backlight the buttons. My intent is to 3D print these. These buttons are just placeholders right now. I think what I'm going to be doing is I'm going to be making them hollow. So these will kind of like be a shell. And I'm thinking that the cap here will be laser cut and laser etched, and it'll glue on. That's what I'm thinking right now. The lettering, let me turn the lettering on. The lettering goes right up against the edge here. So I can't really inset it. I don't think that'll look as good, so I kind of want the entire top surface to be one laser cut piece. Anyway, these tactiles will need to be replaced with either lighted tactiles, or I'll maybe shove an LED up in the space here. So I haven't quite yet decided on the exact approach I'm going to have there. Still thinking that one through. Okay, and then the top plate we already talked about. We need to divide that into 3 separate layers, and then of course all the knobs go on top. So there's those knobs, and I'm not sure why these are separate parts right now. I'm going to have to move those so they stay with this group. Really, I need to change this to an assembly so that I can turn off or toggle all the knobs on and off. Actually, the group will work. Yeah, so if I just move these here, I may have to reposition them. And oh, I should mention that these knobs need to be reworked. I think, so I've got this taper here. That taper's not actually correct. So these should actually be more straight cylinders, kind of like the base here. And yes, I know I need someone pointing this out to me. I need to have a knurl on here, basically a diamond pattern on the edges here. I will do that. I just haven't gotten around to it. Hasn't been high priority yet. Alright, so I think what I'm going to do is I'm going to work on splitting this panel up into 3 parts. So I think for now I'm going to hide I wanted to point out one thing with the buttons. So the buttons are designed so that let me hide the tray. So the buttons, let me hide the top plate. So you can see there's this lip around the plastic button, and that is to keep it from coming out through the front of the UFC, and then the tactile switch kind of keeps it from getting pushed too far in. So they're just kind of, because this board is mounted to the tray, looks like it's mounted to the panel, but it's actually mounted to the tray here. That will keep these buttons secure. All right. Okay, let me hide the tray. This is the part they need to work on. Let me hide the buttons, or the knobs rather. I can't hide the buttons now. I think I'm going to go ahead and hide the displays as well. Boom, boom. Probably should move Scratchpad under UFC panel. It'd be better organized if I did that. I'll go ahead and do that. So I'm going to take Scratchpad and I'm going to move it under UFC panel. And of course now I need to turn it on, and I expected this. I'm going to have to readjust the positioning of it. And it's just vertical height is fine. Not that big of a deal. Should be pretty easy to adjust. All I have to do is match it up with, has to go right under the tray. I mean, not under the tray, under the panel. So I need to turn the tray on real quick. It actually needs to sit on top of the tray, not under it. So let me finish moving that scratch pad. Actually, what I need to do is hide the panel. Very precise. I just eyeball it. It's good enough. So that mounts on there. I'm going to go ahead and change the transparency on this base here. That doesn't need to be transparent anymore. Whoops. I did transform instead of appearance. Okay. Let's turn off this lettering. Don't need the button engravings on. Alright, so now if I hide the UFC panel, everything goes with it, which is good. That's what I want. But for now, we're going to go ahead and turn off the scratch pad because I don't need that. I'm actually going to turn on that, turn this off, and I'm going to probably hide the circuit board for now. Alright, so this is the part that I'm working with. Oh, okay, so the lettering right now is not in a separate group. You may want to consider doing something there with that. I feel like I need to move that into another group. That's going to create an issue, I think. Let's start with a group right now. Alright, so we're in part design. Let's try this. Okay, so let's toggle active body to the top plate. Let's create a group. I need to move that group under the body. Okay, I need to take a pause here. Alright, let's see. What happened? My group went not where I wanted it. What happened to the... Oh, okay, so this sometimes happens. Just messed it up. Top plate just got moved out. So we need to undo that. This happens sometimes. Is that correct? UC panel. Nope. See, it keeps moving top. This is a bug. I've run into this before. I think this is why I didn't fix this earlier. What I may have to do is I may have to make this a part. So let's make sure nothing in the group. Let's delete this group. Okay. Alright. I have to think through how I want to deal with this. I think what I need to do is let's see, toggle active part, toggle active part. There, that gives this the parent. Come on, why can't it just put it in the right place? Now I'm going to do that, and then I'm going to take these guys. Let's see if this works. Ooh, move this under panel lettering. This might get all jumbled up. We'll see. Yeah, so they all just disappeared. And the reason for that is it group. So where is that now? Okay. So what happened here? Let's move these back. I think what I'm going to do is I'm going to create an assembly. Delete this. Create part. Put it under panel. Panel lettering. Okay. But because this is assembly, I should be able to, yeah, so it's just hidden. It's underneath. I just got to shift it. So now I can transform the whole assembly. And yes, my z-axis is upside down. When I created the very first part, I had this thing oriented the incorrect way. And the consequence of that is lots of parts are now pointing like up is down, down is up. I've fixed some of them, but if I were to fix the main part, it kind of screws everything up, and I'd have to move all kinds of stuff, and I don't want to do that. So I just live with it. There we go. Okay, so now it's very easy for me to toggle the lettering on and off on the panel. That's no longer part of the panel. And that's good because I want this piece to be clean when I split it. Okay, so what I need to do is I need to create, I think, what I will do this would be interesting. So I think what I need to do is I need to create a new body. I'll call it panel splitter. Panel layer splitter. Okay. And I think what I need to do actually is I'm going to create it on the XY plane, and I really just need it to encompass the entire panel. And just because I'm anal about this, I'll do some symmetry. Symmetry. Okay, and then I think I will pad this. The middle layer is, I think, going to be 2 millimeters. And what I intend to do here, then what I need to do is I need to transform this. And what I'm really looking for is to go up in the middle like this. Sorry, should the middle layer be 2 or should it be 3? I think I meant 3. So this padding actually needs to be 3 millimeters. So my intent for, wait, what the heck? Yeah. So the bottom plate is going to be 3 mil, the middle plate is going to be 3 mil, and the top plate is going to be 2 mil. Yes, I know these features on the top here, I'm going to have to split that into a separate piece. That is, these are going to have to get glued on. So I'm going to actually, what I might do, I might actually laser cut these and then glue them on. And maybe I could do some sanding to get that bevel. I don't know, I haven't decided that yet. But anyway, back to this. So what I need to do is I need to position this so that it is basically 3 mil up, so that I have, alright, this top plate, or the thickness of this whole thing is bigger than what I had intended. I think on the UFC and only the UFC, the actual panel is thicker than usual. I think. For whatever reason, it's a thicker panel than most panels are. So the question is, do I make that, so this is like 10 mil from here to here. And I'm not certain how I want to do this. Like, the material that I bought for this is definitely 2 mil, so really what I want is like that, because that's going to be the backlit material. I already have that material. I've already bought it. So the question is, how thick should the middle piece should it be? Should it be 3? I guess I could do that. I could make this 3, and I could make this part 3, or I could find maybe 4 mil. I think 4 mil might be harder to find. So it could be, so 3 plus 3 plus this would be 8 mil. So it would be 2 mil shorter than what I think is the real thing. I don't know. So let's position this for now. Let's position this at 4 mil. That may not be right, but that's what we'll do for now. So let's look at the placement here. Let's look at the numbers. And it's saying this bottom part is 6.3. 6. Is that right? Did it move? Yeah. Is that 2 mil? This looks, it doesn't look like this is 2 mil. So here's what I could do. I'm gonna create a sketch on here, on the top plate. I think right now, active body. I'm just going to attach a sketch here just temporarily. And what I'm going to do is I'm going to bring in external geometry. And I'm just going to make a box that is, I'll do it on this end. Okay, and I want to make the height of this 2 millimeters. Okay, and I think I'm going to select this whole thing, and I'm just going to go ahead and make it selection geometry, construction geometry rather. Okay, and then I want to turn on, actually no, I can't make it construction geometry because then it doesn't render. Toggle that back to regular geometry. And what I want to do is I want to show it. This will help me line up where this thing should be. So I'll go back here. And then go back here. think what I need to do is adjust the sketch. Just need to make it go wider. Okay. So now I've got it snapped to that. Alright, so now I've got that positioned where I want it. I can hide that sketch, I don't need that anymore. So you can see I've got this big giant thing intersecting. This doesn't really need to be that big. Just adjust that. So this body is intersecting this body, and I'm going to use this to split this panel into 3 panels. That's the theory. Let's find out if that works. Alright, so I go here. Top plate. Well, first of all, I need to go to Part, Workbench. So we're going to select the top plate, and we're going to select the splitter plate, or splitter body. And Part, Split. And we want Slice Apart. And what I should end up is with 3 bodies, which move outside of the panel, so I have to drag this back into panels. That's why they're not being displayed, because there we go. And now they're back, and if I scroll down here, I can rename this to Sliced Panel. Now you've got Slice 1, Slice 2, Slice 3. And I'm going to do detailed work on each of these, because what I have to do is I have to cut out holes for like the nuts and stuff on the middle plate. So, for example, first let's name these. So this is Slice Top Plate, middle plate, bottom plate. Okay, now for now I'm going to hide the top plate, and what I need to do is add clearance to these holes to allow for the nuts. So if I go select the middle plate, or make that the active body, whoop. What I may have to do, I can't set the active body here, so what I actually may have to do is I may have to create a reference to this and clone it. Fun. Okay. So let's go back to part design. Okay, we're going to clone it, I think. Create a clone. Rename this. This is just a temporary name right now. Middle plate. I gotta move it under USC panel so it's in the right position. So now, if I hide that, this is the clone. Okay, so now we set the clone to active, whoops, not transform. Toggle active body. We'll select the top. Or select the top face. There we go. Now we're in business. And I'll just show you how I do this. Right now I'm just eyeballing it. These aren't going to be the right dimensions. In fact, I'm pretty sure this shaft is too wide, but I'm not sure. we'll measure off the actual parts that I have and get that correct. All right, so let's set this to, whoops, wrong button. 10 millimeters, which would be a 20 millimeter. Holy cow. I guess we'll make it 10 for now. We'll set this one and this one to equal, and maybe this one to equal. They all look the same. Okay. I like some symmetry. And for some reason my Alexa thought I was just talking to her. No, it was not. Just try and get this in the ballpark of where, you know, centered. I can refine that later. This is a button. That's not supposed to be whatever, you know. Let's see. Let's make this one symmetry with this one. Okay. What's the size for this? Ah, keep hitting the wrong button. We want 7, is that right? Again, these won't be the right sizes. I'll come back and fix that later. Just trying to get in the ballpark there. And these need to be equal, so they're both the same size. Okay, now what we need to do is make a hole all the way through. All, okay. There we go. So this is where the nuts would sit. And actually a good question is whether, so this is supposed to be 3 mils right here. Hopefully 3 mils is tall enough for the nuts, for those parts. Should be. These circles might have to be a little bit bigger. I don't know how big those nuts are. Again, I'll measure the nuts and find out what diameter I need in there. You need enough clearance to screw those nuts down because they need to be hidden underneath the top plate. So that was the point of creating that plate. So that was an important step. I see that the colors need to be adjusted on these. Let's see, appearance. I think this is the color I'm using for the panel. I'm going to leave the lower panels a different color just to have it stand out for now. Okay. Let's bring everything back. Panel tray, groups, buttons, knobs. I need to put the knobs all in one assembly. Bring back the scratch pad, bring back the panel lettering. And bring back the rear body, bring back the base. Scratch pad's partially hidden. Bring those parts back. Okay, and then yes, I know the tray is kind of a goofy color right now. It's fine. Alright, starting to come together. Let's put this back into perspective mode. Alright, so that is some more progress, and I hope you enjoyed watching my workflow and how I work on this stuff. It takes time, lots of time. I have a crazy number of hours on the UFC, and I still have so much more work to do. But little by little, I am getting there. All right, have a good one.